Okay, so this question mentions that there is an applied force pulling this way on a 9 kilogram box, and I like to draw my free body diagrams with a dot. So after labeling every force, such as the force of gravity, which is mass times gravity, so 9 times 10, 90, and since it's on a horizontal surface, there will be a normal force perpendicular to the surface, and in this case f of n will just be f of g, mg, which is again 90 newtons. And this question asks us to find the force of friction. Well, essentially, you need to figure out what the force of friction is, and in order to do this, you need to do F net is equal to mass times acceleration. I believe this is Newton's second law. We know that velocity is constant. We know it has a constant velocity of 4 meters a second. So off the bat, that means that acceleration is 0 because the velocity is always constant. So no matter the mass, I know that F net is going to be 0 newtons, always, because acceleration is 0. So what here do we need to add on the force of friction to balance everything out and make the net force 0? Well, simply negative 40, or well, 40 this way, so not negative 40, but 40 to the left, newtons. So now we can go ahead and plug this into the equation we learned from class, which was the coefficient of friction is F of n, or the normal force, times mu. No, this is the coefficient of friction, but the force of friction is equal to F of n times the coefficient of friction. We know F of n is 90, and I'm going to go ahead and substitute mu for x. So 90x is equal to the force of friction, which is 40. Well, how do we solve for x? Well, we simply divide this by 90. When you simplify, you get that x is equal to 4 over 9, which is simplified to 0.44. So mu has no it doesn't have any like symbols after it. There is no unit to it. It's just 0.44. So yeah.